Sorry guys. Okay, here we go. A mass of 1 kilogram is dropped from rest at a height 2.5 meters above horizontal ground. Its coefficient of restitution is 4/7. Find its speed just before impact. Okay, we're going back to UVAST. And your acceleration is 9.8. Your S is 2.5. You drop it from rest, which is U. You want to find V. V squared equals U squared plus 2AS. V therefore equals the square root of 2AS because U squared is 0. So what's the square root of 2 times 9.8 times 2.5? Anybody tell me? I'm going with 7. Anybody tell me for sure? Genius. Now, speed just before impact is 7 meters per second. It hits the ground, so comes down, hits the ground, and it's on its way back up again. Anybody tell me its speed as it leaves the ground? So basically, there is a technical formula for this. It's V equals EU. Okay, your final velocity equals your coefficient of restitution times your initial velocity. Only one problem, it's going in the opposite, so minus EU, because it's going in the opposite direction. So if going down was +7, going back up at a speed of 4 upwards has to be denoted as -4. Is that right? So it's going 4 up in the opposite direction. It says speed only, it doesn't really say velocity, so you don't have to specify the -4. If it said velocity, you'd have to specify that's going up 4 versus down 7. Okay? Impulse exerted by the ball. What's the impulse formula, lads? Anybody remember? mv minus mu. And what's the weight of this ball? 1 kilogram. So 1 times 7 minus 1 times -4. Anybody tell me what that is? 11. What's the units? Mass times velocity. Kilogram ms to the -1. Now, the impulse imparted by the ball. Nice, okay. Find the loss in kinetic energy. Loss in kinetic energy, lads. So loss in KE is 1/2 mv squared minus 1/2 mu squared. What's mv squared? 1/2 1 times 7 squared minus 1/2 1 times 4 squared. Anybody want to tell me what that is? It's 49/2 minus 8. $16.5. Yeah, you're just going to nod to anything at the moment, so 16.5 joules, okay? So 16.5 joules. Now, a ball of mass. Oh, why do we keep doing that? A ball of mass, 2 kilograms movement velocity, 5I minus 8J when it hits a smooth barrier along the I-axis. Coefficient of restitution is 3/4. Find the new velocity of the ball. So, in essence, we're going 5 across and 8 down. That should be a much steeper angle, shouldn't it? The diagram's a bit misleading. It should be a much steeper angle. Because if you're going 8 down, 5 across, you can see that the opposite is longer than the adjacent. Should be a steeper angle. Okay? Now, I'm not nitpicking anymore. Can anybody tell me what happens on the way out? What's the velocity along the I-axis on the way out? 5. And what happens to the 8, or the -8 so to speak? Gets multiplied by 3/4. Direction gets reversed. So the velocity on the way out is 5I plus 6J. No bothers there, okay? Loss in kinetic energy, anybody? This is a hard one to do. Actually, I have a trick for you as well. Okay. Let's do the loss in kinetic energy 2 different ways. And this is important. This is actually very important. Okay. First way of doing it is to get the hypotenuse of each triangle. So what's the hypotenuse of the first one? 8 squared plus 25. Root 89 or something, is it? 25 plus 64, root 89. Let's see if root 89. I think that's a prime number. Yeah. Root 89. 36 plus 25. Another prime number. Now, we're going to do loss in kinetic energy. And what we're going to get is a half mu squared minus a half mv squared. So it's going to be a half, what's the 2 times u squared, which is going to be just 89 minus a half. 2 is the kilogram, and then 61. It's just basically 89 minus 61, isn't it? Why is 89 minus 61? Anybody? 28. So you lost 28 joules. Is that right? 28 joules. What fraction did we lose? Is that the next question, is it? Not yet. I'll just do this one. I want the percentage loss, okay? I'm just going to add an extra question here. Percentage loss, anybody?
28 over 89.
Not 20. Yeah, so you're right. 28 over 89. And what do we get there? I think it just stays the same, doesn't it? 28 over 89. Okay. Let's do impulse on the ball. Okay? So, let's try to impulse on the ball is a change in momentum, right? So what is the change in momentum of we need the impulse is going to be momentum before collision minus momentum after collision. So it's going to be m times root 89. Now it's hard to say because of what? It's also a change in direction, okay? So I think so that's perfect. Both ways are perfect. Okay? So impulse, okay? What we're going to do is we're just going to focus on the part that the velocity changed on. Okay, so if you look at the part the velocity changed on, what is it? It's going to be a half, sorry, not a half, mass by velocity. So it's going to be 2 times 8, yeah, because 8 down, and then minus, I'm going to have 3 6's going upwards, okay, so 2 times minus 6, and when you add them both, it's going to be 16 plus 12, which is going to be 28, what's it going to be, 28 kilograms per ms minus 1. Why didn't this work? Why didn't doing mass times root 89? So why didn't 2 times root 89 minus 2 times root 61? Why didn't that work?
It's only the I component and the J component.
Yeah, and it also didn't change. It didn't take into account the change in direction. Because it'd be alright, it was still going in the same direction, and it slowed down to root 61. It's not changing in the complete change in direction. That takes a bigger amount of impulse to do that. So, long story short, what we've learned here is to isolate the components when you're doing impulse. Okay? Now, number 9. A smooth sphere of 0.2 kilograms hits the smooth barrier along the j-axis. J-axis, so like so. It's going 4i plus 3j. So 4 cross 3 up, 4 cross 3 up. Good there. Actually, so I'm being a bit pedantic about that. There we go. So, what happens this time, lads? 4 cross 3 up. You hit here, X marks the spot, and then on the way out, what happens? Bigger angle or smaller angle? Smaller angle. Okay. What stays the same? The 3 stays the same. What changes? The 4. The 4 is now what size? 4 is 3/4 of what it was, because 0.75 makes that a 3. Velocity after impact, guys, minus 3i, because you're going 3 to the left and 3 upwards. Your percentage loss in kinetic energy, that's a 5, isn't it? 3, 4, 5 triangle. And this one here, root 18. So you're going to do a half mu squared minus a half mv squared. That's your loss in kinetic energy, which is going to be a half times 0.2 times 5 squared minus a half times 0.2 times root 18 squared. So what does that come out as, guys? That's going to be 2.5, yeah, well done. And the other one's going to be 1.8. Yeah? Whoever said yeah, do you actually know it's 1.8? I'm not that good, I've made plenty of mistakes here. Okay, 0.7. You lost 0.7 joules. And how much did you start off with? 2.5. So 0.7 divided by 2.5 multiplied by 100 over 1 will get us... Not doing this one in my head. Nice. Really? Ah, I got you. Nice. Okay, I think we're good. 11. How many questions in this exercise? 15. Ball of mass m falls from a height h meters onto horizontal ground. Find the coefficient of restitution z. Find in terms of g, h and e its speed on hitting the ground. So, falls. Keyword falls. 0. G. H. Find the speed it hits the ground at, guys. This is a very important formula. You're going to use this repeatedly in your course. Phi squared equals u squared plus 2as. Phi squared equals 2gh. Phi equals the square root of 2gh. Done. The speed which it first rises from the ground. It hits the ground and it comes back up again. Phi equals phi equals minus EU, and it's going to be phi is going to be minus E times root 2gh. Is that right? The height it reaches after the first bounce. How do you find the height now? We're going to UVAS this again for scenario 2. Phi is 0, A is minus G, S is, we haven't got a clue, and U is minus E 2 root 2gh. Now, any ideas to find the S value? Phi squared equals U squared plus 2AS. By that logic, rearranging this formula, 2AS equals phi squared minus U squared. S therefore equals phi squared minus U squared all over 2A. Let's try this out. Final velocity is 0. U squared, U equals minus E root 2gh. Square that and what happens? What do we get? Minus 2gh E squared. All over 2 times gravity. Is it minus gravity or plus gravity? Minus, because you're working against gravity, so minus 2g. What happens next? S equals, the minus 2g's cancel, and it's going to be he squared. Anybody tell me the significance of that for any particle dropping underneath gravity? Okay. Let's say, for an example, I have a particle that drops from a height of 20 meters. Coefficient of restitution is 1/2. How far will it rise back up? 20 times e squared. E squared is a quarter. A quarter of the original height. It will rise back up 5. So you can see by deriving this formula, you can keep changing your numbers. I could say, alright, let's go up 50 this time, and let's change the coefficient of restitution to, I don't know, a 1/5. How high will it rise this time? 2, because it's going to be 50 times a 1/5 squared, which is going to be a 2 meter rise. You happy enough with that? 2 meter rise. Stal, do you want it from that question? Yeah. HE squared. Okay. So, excuse me guys. A ball of mass m moves with speed 20 meters per second towards a smooth barrier xy, which makes an angle of 4/3. So, I'm just going to work on this angle, I'm going to call it angle B, okay? So tan B equals 4/3. I'm not going to bore you with the Pythagoras theorem on that, it's 5, okay? So it's going to be cos B is 3/5, sin B is 4/5, okay? What I'm going to do is I'm going to do a little trick here. I'm going to extend my line straight through here, and then because I have the software to do this, I'm then going to group these together like so. And then I'm going to rotate it so that that's now the x-axis, like that. Then I'm going to put my angle B back in here, and now what I'm going to do is I'm going to break up my 20 into its components. So you can see just a change in the tilt of what you're looking at really makes a hard question into an easy question. So what we have is 20 going this way, dot dot dot. And I'm going to break it up into 20 cos B and 20. This is where your projectiles comes in handy. What do we say sin B is? 4/5, so 16 and what's the other one? 12. 3/5 of 20? 12. Now, the question wants the speed after impact. What's the E value? E is 3/4, okay? So what we're going to do next is we're just going to, I can turn this back now, just confusing me now at this stage. So what we're going to do is we're going to assume it's like a snooker table, so gravity isn't going to be affecting it whatsoever, okay? No air resistance, no gravity, okay? So we're hitting the barrier is now changed to this part down here, and now it's going to bounce back upwards at a smaller angle than it was before. Which part gets affected, lads? Huh? The exits at 12 and the 16 gets changed into what? Huh? 3/4 of 16, anybody? 12. 12/12. Velocity after impact. The speed of the ball after impact. So guys, we have to get the hypotenuse. 144 plus 144 makes square root of 288. Alright? 12 across 12 up, so root 288. The magnitude of the impulse. What did it tell you about how to get the impulse? How do you get the impulse again? You take your components away from each other. So what's the mass of the ball? Anybody know the mass of the ball? Does it tell you the mass of the ball? Just m. Okay, so that's alright. So mu minus mv, so it's going to be I times 16m minus 12m. Do you notice we're only taking in the j component there? The up and down component. So the answer will be 4 times whatever your mass is. Okay? Loss in kinetic energy, anybody? Loss in kinetic energy? 1/2 m times 20 squared. What's 400 minus That's 288, isn't it? Minus a half m times root 288 squared. What's 400 minus 144? Or sorry, 200 minus 144? 56. M is your loss in kinetic energy. And finally, the tan of the angle between the ball's new path and the horizontal. Now that's going to be interesting. Okay, so, and the horizontal. Okay, my angle A, lads, is in here. Do you see that? That's my angle A, isn't it? See angle A here? Angle A is what? 45, isn't it? Because it's 12 and 12, that gives me my 45. And can somebody tell me what is tan inverse 4 over 3? Tan inverse 4 over 3. So we're talking about this angle in here.
45 as well.
Tan inverse 4 over 3. It's not 45.
53.3.
And then add them both together. What do we get? 98.13. That's your change in that's your difference in your old path compared to your new path, because your old path is going straight through and its angle gets adjusted outwards. Okay guys.